Hello, today we will once again get to equate equations using a special mathematical method. But let's see that the equation I propose to equate now has an ionic molecular character. That is, there are ions along with the molecules. But it turns out that we can equate such unusual equations by this method. So let's remember that first we have to put letter coefficients in front of the formulas. So in front of bromo 03, we'll put the coefficient A. Now next, in front of the formula bromo 2, which we have bromine and this, let's put the coefficient B here. Now let's find out what coefficients we're going to put in additionally. So we put A in front of bromo 3, so we have 3 in front of the water formula. And because oxygen comes in here with the same amount, correspondingly in front of the hydrogen formula, look, here in front of the hydrogen ion we'll have a factor of 6A, and then we're left to deal with bromine. Why have we done that? Because the bromine that you get on the right hand side is sort of a joint bromine, obtained both from here and obtained from here. It's combined. Then here we can see it's 2, so then the bromine coming in here, it's going to be 2 B's, that's 2 B's, minus this A here, minus the A. That's how we got the letter coefficients. And now, as usual, we're building a mathematical pattern. So for the element bromine, we have it on the left-hand side. A plus 2 B's minus A, that's on the left-hand side, and on the right-hand side we've got 2 B's. Now oxygen. Oxygen on the left-hand side we have 3 A's, and on the right-hand side we have 3 A's as well. And hydrogen, now hydrogen, which we get an ion, so on the left side we have 6 of it, and on the right side of it we get 6 A's as well. Now, what equation are we going to start from? We're going to start from, look, this is the one here. What's unusual about this equation? It would seem that how can we calculate from here? But there's a pattern that means as much as we have the sum of charges on the left side, the same amount of charges should be the sum of charges we get on the right side. But on the left-hand side, notice we have 2 ions, a minus ion, a plus ion, and since on the right-hand side these are all neutral molecules and their charges are 0, as in the formula bromine 03, there is a pattern that follows from here that this is the number obtained for bromo 3 and for hydrogen between themselves must be necessarily equal. So it turns out that 2 B's minus A must equal 6 A's, because as many minus charges, there must be as many charges and plus, because there is a rule of conservation of charges, so you must have a total of 0. And then we get from this expression, so we solve this equation, we get 2 B's, and then A will be equal to 2 and B will be equal to 7. Here we have got the regularity of these numbers. Let's put them then, because in the obtained coefficients, so A is 2, so we'll put the coefficient of 2 here. Now B is 7, so then right here in front of the formula bromo 2 will be 7. Now further hydrogen is 6A, so 6 times 2 is 12, and here is 3A, so we get 6. And it's left to figure out what the coefficient in front of the bromo 2 ion would be. 2 B's is 14 minus 2, so that would be 12 in front of the bromo 2 ion. And so our equation is 2 bromo 3 plus 12 bromo 2 plus 12H plus equals 7 bromo 2 plus 6H plus 2 O's. One more time and we get this equation. equated through the mathematical method of matching. But the example is interesting because we had to use the rule of thumb to keep the total charge. It turns out that what must be 0 on the left must be 0 on the right. So the example is quite curious in this respect because we have also applied the algebraic method and the method of equality of charges here. Well, I hope this method of equalization is clear to you, and there are other methods that we could talk about. Garcia's method, for example, which is sometimes used for equalization. But of course, in such equations, and these are redox reactions, we can select coefficients by the electron balance method and by the electron ion balance method. And we will also talk about these methods in our lessons, so I think it makes sense to look at them. Well, that's all for today. Goodbye.